A very good afternoon to all of you. I'm Meenakshi. Welcome you all on behalf of Solar Quarter and First View Group on today's masterclass on maximizing solar power with Huawei's innovative storage solutions for homes and businesses. I take the pleasure to thank our partner Huawei for their immense support to organize this event and to Mr. Mohammad Ayub, who is going to be our session expert for today's masterclass. In the Middle East, there is a tremendous expansion of the use of green energy solutions, with resources ranging from wind, solar, and hydropower to nuclear power and fossil fuels, demand-side resources, and system efficiency assets. Energy storage is a key hub for the whole grid. Sometimes it performs the functions of generating, transmission, or distribution as all in one. In this masterclass, we will learn about Huawei's intelligent power made solution, which is the iSitePower-M and the Smart String ESS. These products are the perfect choice for users for residential, commercial, and utility solar plants because they provide dependable power around the clock in a flexible and small footprint configuration of power and battery. Here, I would like to make a small announcement. Attendees can post their questions in the Q&A chat box, and our speaker will try to answer those at the end of the session. Now, without further ado, let's initiate the first part of this masterclass on transforming the residential solar storage systems with iSight Power M. Over to you, Mr. Ayub.
Yes, thank you very much, Meenakshi. Hello, everyone. Very warm welcome to the session. In this session, actually, we have two products. We are launching two new products to the Middle East market. One is iSitePower-M, another is the C&I energy storage solution. And these are our unique products we are launching into the Middle East market, especially with the battery energy storage components included in these components. And these are our advanced products having futuristic components and benefits into the product embedded into the system. It also has components around related to artificial intelligence, big data, and cloud management. So without any much ado, I will start with iSitePower-M, which is our new product. We'll be covering first iSitePower-M product now. So iSitePower-M is all-in-one hybrid solution for reliable and continuous power supply in Middle East market. It is a basically hybrid solution which integrates the solar, DG, battery, and the grid. So in this presentation, I will cover current situation and challenges in the Middle East market. Then we will see the iSitePower-M introduction and system configuration. What are the applications and solutions possible with the iSitePower-M? Coming to the current situation in the Middle East, especially the electricity supply sources and difficulties. So if you are observing the markets like Lebanon, Iraq, and Pakistan, and the Oman and Saudi Arabia, there are some places where the grid is unstable, especially in the Lebanon and Syria. So there is an unstable grid and there is a frequent grid power cutoff. So there is no reliable power supply available for the consumers. The consumers can be household consumers or industrial consumers. So they do not have reliable power supply. So what they are doing is they are depending on other sorts of supply like diesel generators. But the problem with the diesel generators is very expensive, and also there are freight related issues, shipping of the diesel to the sites. All those complexities are involved. Also, the overall the solution wise, it's very complicated. You need a system which is a hybrid, switching from this grid to the diesel generators, and it needs a lot of electrical knowledge and electricity as engineering experts. So that is the one challenge we are seeing in the Lebanon. Similarly, in the Iraq as well, there's a power outage for around more than 12 hours. So half of the day they have to depend on some other energy sources. If the customer or the end consumers does not have enough financial capability, they have to live in a dark conditions. So other option is to go for the diesel power. Again, the problem is the same. There is a chances of frequent failures of DG if the system is not integrated properly, and there's also high electricity charges for DGs, and the rate of return also very expensive when you have a solution with the diesel generators. Now, if you see overall in this, especially these markets like Lebanon, Iraq, Syria, the challenge is that they do not have the reliable grid supply, and they have to depend on another source of diesel another source of supply like a diesel generator, and it makes the overall system very complicated and expensive. So we can summarize that in the Middle East, the challenges we see is that electricity shortage, wastage of solar power generation, because even though we have high sunshine in the Middle East area, you will not be able to store any energy. So you have a solar, use it to consume. If there is no load, you have to curtail that excess solar energy. So we need the sources, we need a system like a battery system where we can store this excess energy and use it in the later on. So those solution we will see in the coming slides. So one option is to go for adding the battery into the system. So when you add the battery into the system, there are other challenges also is there, because the batteries, especially lithium batteries, are considered as dangerous goods. There is always a possibility of fire, explosions. So we need a system, reliable system. And if you see in the market, there are some cases in Pakistan, Iraq, and Lebanon. They have already integrated batteries, but the lack of clear understanding of the battery chemistries, which chemistry has to be used in which application. So this knowledge is not available in the market so far, and also the available solutions in the market are not technically very viable, are not technically very sophisticated. So if you see this one in the Lahore last year, we have seen a couple of incidents in Lahore where there are multiple fatalities. There has a battery explosion happened, and the major reason for battery explosion is that battery limitation for outdoor installation, especially when you're installing lithium batteries has some temperature limitation as well. So we need to be very careful when we're adding batteries into the outdoor environment. We need to have some kind of proper ventilation, proper cooling mechanism to have the battery performing very well at these temperatures. So in the Pakistan, the issue was that battery were installed outdoor. So whether it is not really looked into the chemistry, whether this chemistry is reliable to install outside or not, and also improper and uncontrolled battery cooling. So those are the challenges we have seen in the Pakistan. If you take another case in the Lebanon, so there was the issue with the overheating. So battery went into overheating because the unreliable charging and discharging process. Because we also need to be careful about how are you charging, how are you discharging, are you doing overcharging, over discharging, what are the SOCs and DOD conditions are there. So those are the things also has to be monitored and properly selected when selecting the battery technology. So if you see the overall battery faults we have seen predominantly across the globe in the Middle East, is mainly because of lack of awareness around the battery chemistries, lack of proper uh, temperature control mechanisms, and also DC arcing fire hazard and battery overcharging and fire hazards, and DC electric shock hazards. These are some of the main reasons we have seen in the Middle East markets for battery explosions, and the safety concerns are related to battery. So we will see how these challenges we will solve through our product iSitePower-M. iSitePower-M introduction. Let me play a small video just to get an idea about how the product looks like. Yes. So this is our latest product, Intelligent Power Mate iSitePower-M. So the benefits and advantages, key features in this product, I will explain more in detail in the coming slides. So one of the key advantage we are bringing with this product is the reliable 24 hours power supply. So with this product we can integrate grid, we can integrate diesel generators, we can integrate solar and the battery. So you have multiple sources available, and this product comes with integrated technology where based on the availability of the sources, it will transit from one source to another within very small time duration of less than 20 milliseconds. So that is a one key advantage. So 20 milliseconds is such a small time, you will not realize there is a power interruption. Such a fast transition from the one source to another source we can do with the iSitePower-M. So you will not even feel that there is a power outage. So as I mentioned in this one, we can also have a grid. We can also have the diesel generator. We will see more into that, how the system will work when you have multiple sources. Here is a small video. Again, I'm showing you just to give an example how this particular villa being powered when we're having iSitePower-M. So during the daytime, its battery is getting charged from solar, and the battery excess solar energy coming from the solar is getting, 1 second, yeah, excess energy coming from the solar is being given to the battery and also fed to the load. When when solar is not available, especially during the night time, the iSitePower-M will discharge the battery and provides the continuous power supply. So here in the during the daytime, we also have the option of going with the solar, also with the grid. If the solar energy coming from the solar plant is not enough to power the load during the daytime, we can use the grid. And also in the another case, what we can see is when we have diesel generator, how the system will work, we will see in the next example. So in this one, what we can say is that we are giving reliable 24-hour power supply, and we are increasing the penetration of solar energy, and we are also providing active safety and smart O&M. Now in this one, you can see here, let me take pointer. So if we can see in the left side, this one, the upper one is the called the power module, which is a 5 kilowatt capacity, and the lower one is the battery module, which is again 5 kilowatt hour. So when we have our system supports the 0.5 C application, which is a 2-hour backup. So only in the condition where we have one backup, one power module, one energy module, we limit the power to 2.5 so that the C rate is 0.5 C. But in other conditions where we have two battery modules, this power module will work under the 5 kilowatt. So you can see 5 kilowatt by 10 kilowatt hour. And another option we have is we can connect maximum 3 battery modules. So in this one, the power module is a 5 kilowatt, and we have 5 kilowatt hour, 5 kilowatt hour, 5 kilowatt. So we have 3 battery modules. The overall energy capacity is 15 kilowatt hour. So how we will select these battery modules? It depends on the how many hours of backup you require. So based on that, we can select either 1, 2, or 3, and also we can connect multiple systems in the parallel. So that I will again explain in the coming slide how we can increase the capacity even more than 15 kilowatt hour, because right now you can see is the 15 kilowatt hour. We can connect more than 3 up to 3 in the parallel. That will make the overall capacity as a 15 kilowatt by 45 kilowatt hour. That configuration I will explain more in the detail. So that the main advantage what we are seeing is that we have the system which is modular in the nature. Based on the customer requirements, we can add more and more battery modules and give you the more required backup power. So if we take one example where we have solar, grid, DG, and battery, how the system will work, we will see in this example. So here we have multiple energy sources available. We have the option to set the which source to use. We can set the priority of these energy sources. So we have this option in the app. We can basically control this whole system through the app. We can set the priority saying that solar is my first priority. I want to use solar first, then I want to use the battery, then I want to use grid. Like that, we have the flexibility of choosing which source to use when. So in this example, the priority we set as a solar is the first priority, battery is the second priority, and the grid is next, and later on the DG. So in that case, if you see there's a load curve, which is a green color one. So there's a flat load curve is available here. So we can see here from the midnight 12 o'clock to 3 o'clock, we are using the battery grid. And once the grid after 3 o'clock, we are using the battery to discharge till the solar comes from the daytime. Once the solar comes and produces energy, we will give that energy, excess energy, to the battery. Also give the solar energy to the load. So till this system will work till the evening 4 o'clock or 5 o'clock. After that, solar generation will start coming down. Then we will again access the main supply. So this is a one example when we have multiple generation sources, how to use the system and how to set the priority of the multiple energy sources. So if you take another example where the main idea is to maximizing the self consumption. When I say the maximizing the self consumption, meaning that we have to use effectively all the energy available from the solar. So because sometimes when you do not have the battery, so solar energy, even though it's excess, it's more than the load. The excess energy is either curtailed, either clipped, and we are not able to fully take the advantage, or we're not able to fully leverage the potential of the solar. But when you have a battery systems embedded into the system, we can maximize the solar generation. So we can say the system is more greener, and it is working on the solar alone for the longer hours. So in this case, we have a grid, we have solar power, and we also have a DG. And that we are what we are trying to do in this maximum self consumption is trying to reduce the dependency on the grid and DG, and use more of a battery and solar. So we have seen the reliable power supply. That's fine. Now we are going to see what are the experiences, like what are the intelligent components we are adding into the system. Let me play a small video here. So you can see this iSitePower is IP66. It's completely outdoor. You can place it outdoor. You can also place inside the home. And especially this product is coming with the high safety features, because this product uh, is a residential product. So there is a high probability of that kids and the humans will be around this product within very near proximity. So we are having system where the cables and everything is integrated into the product itself. It is not exposed outside, so in a way it's safe for the people who are moving around the product. So this product comes with a natural cooling. We call it the matrix technology, as you can see in the side of the system. So we do not need any external air cooling or the forceful air cooling. So this system is having the airflow in such a way that the internal batteries and everything can be cooled within the required temperature. And one key advantage we are bringing with this product is that it is a sleep level mute. So we'll see this details in the coming slide. So as I mentioned, the key advantage with this one product is that since we are saying this product is can be installed inside homes, inside the offices itself, we need this product to be absolute to be a noise, very low noise. So this product gives the noise of even less than 29 dB. As per the ISO recommendations for the products which can be installed inside the home, they need product to be having minimum sound noise of 30 dB. But our product, it does better than that. It has the noise level even less than 29 dB, and it also has the efficient heat dissipation, because when you are saying the battery, as I mentioned, that you need to maintain the battery in a certain temperature in order to elongate the life of the battery and also get the maximum performance out of the battery. So we are bringing a technology which is a very safe and reliable, also efficiently removes the heat dissipation from the battery. And this product is IP66, so we can put it outside, we can put it in the rain as well, in the water. It is exposed to the dust, it is not even problem. It is rated at the highest safety level. So another key advantage is that this product is having a app management. So we can monitor all the key parameters like a device information, power supply information, power usage information, how much solar energy is generated, what is the status of the diesel generators, how much diesel consumption is being done, and grid power outage, when the grid is available or not, and how much energy we are importing from the grid. All those data we can monitor from the app itself, and it can be done through the mobile itself. And we have an app called Fusion Solar app. All these key parameters we can track in sitting in the home or sitting outside the home, in the offices, etc. We can monitor all these parameters. What it gives is the advantage is that if any problem, if anything goes wrong in the product, we can see from the app itself, then we can take preventive actions. Safe and reliability. So we are saying the product is available for 24 hours, and it has very good experience in terms of the noise, in terms of the IP protection level. Everything is there, but the product is not safe. It is not safe for the thermal runaway issues, overcharging and discharging issues. Then that does not matter, because say for Huawei point of view, safety is the utmost priority to us. We put a lot of emphasis on providing the product which is more safe and most reliable to the customers. Especially this product is being installed in the houses, in the people where are are placed very near proximity to the product. So we are having a product, we want to bring a product which creates the value to the customers, gives the utmost safety to the customers. So we have added multiple components in the safety of the product. So we have chosen chemistry itself, which is very safe at the higher temperatures, does not release oxygen or any chemicals or any hazardous material at the high temperatures. So we are choosing LFP, lithium iron phosphate technology. it is considered very safe across all the available lithium technologies available in the market. So we are selected such a chemistry, and we also have done multiple certifications, internationally recognized IECs and Intertech have verified the product, have given the certification that this product is very reliable, safe, and complies to the multiple IEC standards requirements like NFPA and NFPA 9540 and multiple certification we are complied through this product. And also we are embedded a lot of sensors in the product from the cell level to the pack level. What gives us the advantage is that we can monitor all these parameters at the minute level, whether it's over current or over voltage or the temperature. All these parameters we can monitor in the real time basis, and so that the product we can identify if something goes wrong, we can take preventive actions. And we'll also have, as the last option, we have added extinguishing bag. So we are saying chemistry is safe, and we also have monitoring at the cell level. We have necessary circuit breakers and necessary protection inside the product as well. Even after we are adding another safety protection, that is the extinguishing bag. If there is after all these components still there is a fire because of some issue, we have extinguishing bags to extinguish the fire and to control the propagation of fire to the adjacent areas. So when we have a product which can be connected to the grid, there's a possibility that there can be some sudden surges on the grid, sudden loads can be added to the product. In that case, we need a product which is reliable, which can withstand to the high voltages. So our product comes with a very huge wide voltage jump, so it can withstand even the voltages of even under voltage up to 90 volts, and the high voltages even 300 voltage. So it has very wide voltage jump range to withstand, and so it gives us the customers the satisfaction and the reliability that even if some sudden surges comes onto the grid, it will not affect the system, it will not trip the system. On the same level, when you have a system where we are connecting high loads, especially the induction loads, especially when you turn on those loads, there's always a possibility of high currents coming onto the current. So we need a system which can withstand high currents even for small duration without even tripping. So our system can have suppose the high currents even 1.5 times of this rated capacity. That's a huge advantage, because especially when you have induction loads, there's a 100% chance that the high currents will come onto the system, and we need a system which is reliable even for such a high currents. So iSitePower-M has those both advantages over voltage and over current withstanding capability. Now coming to the battery charging, what are the key benefits we are bringing? We are adding something called power optimizer. We're adding optimizer in each and every battery pack, so which gives us multiple advantages. One, we can charge and discharge each battery pack independently. Even if there's some issues in the one pack, it will not affect the other packs. We can continue to charge the pack. So if you take one example here, on the left hand side, we have a traditional solution. So if there is some issue in one pack, let's say in this pack there is some issue and we're not able to charge 100%, because all these packs are in the series, we have to stop the charging of all the packs, because it does not have the capability of independently charging and also independently discharging. The products available in the market, they do not have those options. But in our case, if one pack, especially this, let's say this middle pack, has some issue, some fault, and it is not able to charge 100%, it is stopping at 95%, we can bypass this particular pack and continue to charge the remaining packs. So that means that we can fully utilize the batteries even if there is a fault in the one battery pack. So that's why we are seeing with our product we can have more than 3 to 5% more usable energy. Same philosophy applies when discharging also. When you are discharging and one particular pack, let's say this pack is 5% discharge, and because of some fault we are not able to discharge up to 0%. But in that case, we can continue to discharge other packs because they do not have any fault in that. But in other solutions available in the market, you have to stop discharging because one pack has some fault, and we do not want to over discharge the battery, because overcharging the battery or discharging the battery can lead to the faults and can lead to the fire issues. So another advantage with having the pack optimizer is that we can mix old and new battery racks in the system. So let's say here we have some issue. Let's say we had issue in this particular battery pack. We replaced it with entirely new battery pack, so which has more capacity. As we know that battery over the lifetime degrades. Now this battery, because these are old battery packs, may have already degraded, may have lesser capacity, but we can mix old and new, because we having optimizer gives us the advantage of independently charging and discharging. Even the old battery pack has maybe different voltage, new packs will have different capacity, also different voltage. Typically we cannot mix old and new because of voltage differences, because also difference of available energy capacity. But with the optimizer we can able to integrate both. And the available other available solutions in the market, they do not give you the option of mixing old and new battery packs. Let's say you have old battery packs which are already 20% degraded, only 80% capacity is available. So even though you are adding new battery pack, even that you have to use only 80%, you cannot use 20%, because if you are pushing this battery to discharge, you are indirectly pushing other batteries also to discharge, but they do not have any capacity left, and that can lead into overcharging and discharging. So that is one key advantage we are bringing with the pack optimizer. And last but not the least with the pack optimizer is that, since we have this option of independently charging and discharging, so if there is one issue, we can bypass this particular pack, and we can manually go and replace that pack with a new one. So we can bring back the voltage of that particular pack to the 0 volts, so that the person can go and handle that product without having any issues related to the safety. So like I mentioned, so we have an option of bringing the battery pack to voltage level to 0 volts, especially during the maintenance activities when we have to replace the product. We can do that by pressing one button on the product itself. It will bring the whole system voltage to the 0 volts. So it's called emergency shutdown to voltage zero, for doing any operation on maintenance activities. So we have seen all these key features. Now we'll move into the solution side, like what are the different combinations available, how to select the product, how to size the product itself. We will see in this coming slide. So as I mentioned, so we have one battery module, three battery modules. So this again, the flexible, we can choose how many battery modules we need based on the customer requirements, how many hours of backup is required. Based on that, we can select. But if you see on the right hand side, so we can have even one battery module, which is a 5 kilowatt. We can have multiple energy battery modules itself. So this is the 6 kVA by 15 kilowatt hour. But if your power capacity still is the same, but you need more energy capacity, you can just add the more battery modules. So here you can see 6 kVA, 20 kilowatt hour, and I'm adding another battery module. So it's a 6 kVA, 25 kilowatt, 6 kVA, 30 kilowatt hour. So we can go up to maximum 6 kVA, 30 kilowatt hour with one battery module. But we can also connect multiple power modules in parallel. So in this case, we are connecting two iSitePower-Ms in the parallel, and we are having the power capacity of 10.8 kVA and the energy capacity of 30 kilowatt hour. Same way, we can have maximum three in parallel, where the power capacity is 16.2 kVA and the energy capacity is 45 kilowatt hour. So we can play with the power capacity. We can also play with the energy capacity. Let's see some of the examples of applications where the system can be used. So it can be used in the hospitals where they need the reliable power supply, because there are some people are in the critical care condition. They need the reliable power supply. Maybe they need reliable oxygen, etc. And in those conditions, we can use iSitePower-M, because it has the multiple energy sources can be integrated to this product. So even if there's an issue in one energy source, we can move on to another energy source, and customers, especially the hospital, will not face any interruption of power supply. And also it can be installed in the villas and powers where they do not have reliable power supply, or they want to move towards the green energy, move towards solar energy, and want to improve the solar penetration. They can add this iSitePower-M. And it also can be used in the universities where they are having some exams. As we know that exams, we also do not want any interruptions. So it can be used in shopping centers, in the houses where they need reliable power supply, and when we also want to reduce the dependency on the diesel generators. In those scenarios also, we can use iSitePower-M. So that's it for this presentation, iSitePower-M. If you have any questions, I'm happy to answer. Over to you, Meenakshi.
Mr. Ayub, we don't have any questions for now for this session. Okay, we have one question. I'm going to display that on the screen.
Yes, iOS app also supported. Yes.
Okay. With that, we will move on to the next part of this masterclass, which is on smart energy management for commercial solar systems with Huawei Smart String ESS. Over to you, Mr. Ayub.
Yes, give me a couple of minutes. Let me open the another slide. So my slide is visible, right? Hello.
Yes, Mr. Ayub, your slides are visible. You can proceed.
Okay. Moving to the second product, which is our Fusion Solar C&I Smart String Energy Storage Solution. It is, if you have seen our utility scale solution, which is a 20 feet container, 2 megawatt hour battery supply. It is similar to that product, but it is smaller in the capacity, and it's in the cabinet instead of the container. So I will explain the key features and advantages and what are the key values we are bringing to the customer. So in this slide, I will mainly cover the industry challenges again for the product itself in the energy storage technology itself. What are the challenges in the market? Then we will see the product introduction, or what are the key like technical parameters of the product. Then how this product can be used and where it can be used. What are the application this product will support, and some of the reference cases we will see. So coming to the safety, coming to the key challenges for the energy storage. So wherever we have lithium batteries, so there is always possibility of fires. There is always possibility of thermal runaway, maybe because of the temperature issues, maybe because of lack of awareness about selection of the right technology, or maybe not properly designing of the system or interconnection of the system itself. Maybe it could be circuit board issues or the connector issues. There could be n number of issues. The major reason we see in the market, especially across the globe, is that thermal runaway, where the fault in one cell level or the battery pack level, it is escalated and went into the overall system level. So another challenge is that the low available battery energy. So if you see in the market, especially for the developers, this is very important. So if some supplier is committing some capacity, let's say 2 megawatt hour, uh, but they are not actually getting the whole 2 megawatt hour energy capacity usable to them, maybe because of the some issues with related to depth of discharge, or maybe the battery performance itself is not performing as expected. So this will again affect the financial models, the LCOS, all those parameters will get affected. And the major reason we see is that the mismatches in the batteries, especially when you connect a lot of number of battery cells and packs in series and parallel, there's always a chances of mismatch losses in the system. And we will see how we are mitigating those challenges into the product. And another challenge is we see in that batteries are not working as long as we actually, you know, the committed. So during the project design size, suppliers may commit like a 10 years or 15 years, but actually once the battery starts performing, once the project is commissioned, the batteries are not performing up to 10-15 years. And there are multiple reasons, maybe because of the not properly controlling the temperature for the batteries, or having improper distribution of the temperature inside the containers. So those are some of the reasons why batteries are not performing as committed values. And one key aspect again with respect to cost itself is that the O&M cost. So there are a lot of challenges related to the batteries, because these batteries are very complicated when compared to the solar. Solar is maximum we have to do is the max solar module cleaning and the transformer and other things we have to do regular maintenance activities. But with the battery, there is another key component is getting added, that is something called SOC balancing, SOC calibration. And if some activity has to be done, some fault has to be rectified, you have to send people at the site, and it involves a lot of man hours, involves a lot of logistic cost as well. So all these components are adding up to the high O&M cost, and having high O&M cost again reflects into the not so good LCOS values. So the again, if you see all these things at the end of the day related to LCOS, if you have a file, LCOS does not matter, your system whole system is gone. And if you have a low available energy capacity, which means you have lower throughput values, again it will affect the LCOS of the whole system itself. And the battery life, again, if when during the financial moding, if you consider 15 years, but battery is actually having life of 10 years during the operation, again your LCOS values will get affected, your financial mode get affected, your rate of return also gets affected. So all these challenges are there for the developers and EPCs, and we are trying to solve these issues with having adding technology into it, adding artificial intelligence, adding the smart features into the product. So we'll see how we are doing that in the coming slides. So this is our C&I energy storage system. As you can see on the screen, this is a 200 kilowatt hour, 100 kilowatt hour system. This is a cabinet model system, contrary to our utility solution, which is a container solution. This is a cabinet system, but but if you see here, all the components like a PCS, smart rack, auto controller, everything is embedded on the system itself. So that will reflect in the lower balance of plant cost. Let me play a small video of the product, how it looks like, and how the internal components looks like. Okay, all right. So let me give a small technical specification of this product. So like I mentioned, this product is having, in terms of the energy capacity, is 200 kilowatt hour. It has 12 battery packs embedded into the system. So you can see 12 battery packs installed. And this product supports the C rate of 0.5 C or less. So as you can see, our product power capacity is 100 kilowatt and energy capacity is 200 kilowatt hour. So it supports up to maximum 2 hour backup, and it has the weight of less than 2.8 tons, including battery packs and everything inside the system. And the IP rating is around IP55. So this is a perfectly outdoor system. We can put it outside the environment as well. It's not an issue. So these are the specifications for the battery system. If you see on the PCS level, I don't want to go all the technical specification, but I will tell you the basic ones. It has a high operating voltage range, so 570 to 1100 volts, and it has the high efficiency of up to 98.4, and it is again IP66 rated, completely outdoor, even having better IP rating more than the battery itself. And it has the temperature range of minus 25 degrees to plus 60 degrees. So especially for the Middle East regions, where we have higher temperatures around like 45-50 degrees, this product is having 60 degrees, so it's well within the range itself. We can use it there itself. So let me give me some examples about the solution itself, like what are the different combinations possible. So this particular product can be used in two scenarios. One is the git following mode, another is the git farming. So in the git farming is more like in a backup system, more like a microgrid system. We can use it. On the left hand side, if you see this is the grid following mode, where you have existing grid and you are connecting the energy storage system. So there the application could be time of use. You want the battery energy storage system to be used in particular hours to charge and discharge, or maybe you are using for the peak shaving, or for the application of charge and discharge management. So these applications are possible in the grid following mode, and we do not need any external components like a third party components. So all these systems can be monitored from our smart PVMS, our optimizer, solar inverters, a battery energy storage system, meters, a SACU. All those things can be monitored and controlled from the smart PVMS itself. And the key advantage what we have here is that, especially for the grid following mode, we do not need EMS or isolation transformer or any external components which are required in the microgrid system. Because in microgrid system you may have the diesel generators, or you may have multiple energy sources available. And when you have multiple energy sources available, so the system is more complicated. So you need an external third party component like EMS, which to control and give the instruction to all the available energy sources and the loads, and to actively use and prioritize which source to use when, and during the which time we have to use the solar or the battery. All those intelligent algorithms goes into the EMS. So we have some EMS suppliers which are available with us, which have we have done testing with them, especially like a Comap and Elam, and we are compatible with these EMS manufacturers. And we are doing more and more tests with the other available suppliers in the market as well. So once we done the testing, we will have the full and final list for the which are the EMS suppliers compatible with our product. So overall, if you see in this product, we are adding the option of this product is can be added with the PV and ESS. So EPV and ESS collaboration is happening. So we can improve the solar energy penetration. We can have more and more solar energy available. We can have higher solar energy capacity also added into the system, so that it can be charged from the solar to the battery. And also we have multiple active safety uh, features in the product. So I will explain more in the detail in the coming slides. And the reliability itself, since this product can be operated in the both on grid mode and off grid. So for the customer point of view, where they need the reliable power supply, it gives a continuous power supply without having any interruptions. And coming to the more energy, again, this is more like similar to the what the advantages with the optimizer I have explained in the earlier product itself. Similar optimizer we also have in this product as well in the every battery pack. So the key advantages like more energy, more availability, and isolation of the faulty packs. All those key benefits we are having with the optimizer. And the smart O&M, we will see more into the automatic SOC calibration, how we are doing, why it needs to be done, what are the challenges if we are not having automatic SOC calibration. So those things again we will see in the coming slides. Coming to the architecture, we have the distributed air conditioners. That's the item number one. So we can see two air conditioners are installed on the battery rack door itself. Why we are having distributed air conditioners? Because we want to maintain uniform temperature inside the cabinets. So when you have where you have huge temperature difference inside the cabinet, the battery degrades very differently. So we need a system which is effectively maintains the same temperature inside the cabinet, so that the battery degradation can be precisely estimated and give the guarantee to the customer. So that's why we are having distributed air conditioners instead of the one central air conditioner. And the second component is the battery pack and optimizer. So if you can see here, we have 12 battery packs. Again, this is again lithium LFP battery technology we are using, as it's most safe and reliable. And we have up to 12 battery packs we can install. And we are adding more and more flexibility into the product. This is when you have 12 battery packs, which is like around 200 kilowatt hour. We also have the option of reducing the battery packs to meet the customer requirements in terms of the energy. So those products also we are launching soon. And the fourth component is the battery rack controller. This is again to stabilize the DC voltage coming from the PCS and discharging towards the PCS. We are maintaining the uniform DC voltage range for the optimum performance of the system. And the fifth component is the very key product, which is the PCS. You can see on the left hand side of it. It's mounted on the cabinets itself. This is the bidirectional inverter. We can call it inverter. When we are charging the battery, it basically converts AC to DC, and when you are discharging, it converts DC to AC. So it works both way conversion, and also we can charge from the solar, we can charge from the grid. All those options are available with this PCS. And the PCS is the component which is the one who is determining whether the system is grid following or the grid forming or off grid or microgrid. All those things are actually happening to the PCS. So PCS is very important. It gives the connection to the grid and the multiple loads through the system. And another key component we're adding is the emergency stop switch. This is again for the last minute fault control feature. So if there is a fire and any issue in the cabinet, you need a one switch to turn off the whole system, and that is like a last scenario in case of fire and anything. So we can, just by pressing this emergency stop switch, we can bring a whole system to shut down. So this is very useful feature for the safety point of view. And another key product we're adding is the fire extinguisher module. Again, this is from the safety point of view. If in case of any fire and any smoke issues, this fire extinguisher module will get enabled, and it will control the fire within less than 10 milliseconds. Coming to the active safety, so we are giving multiple level, four level active safety and multi-level passive safety features into the system. So if you see here on the right hand side, we have a cloud BMS. So we can monitor the entire system from the remote itself. We can see each and every cell and the pack performances. We can monitor the current voltage of each and every component, and we also embed a lot of sensors in the system itself. So all these things we can monitor from the cloud BMS. We can take the necessary actions. And having the cloud BMS, the major advantage is that we can predict thermal runaway with 24 hours before it's actually happening. So thermal runaway is the leading cause of the fire. So we can able to predict 24 hours before it means it's a huge advantage to the customers, and we can effectively eliminate any fire issues. Everything in very advanced. We can be very proactive in terms of the safety of the product itself. And the next feature we have is, after pre-warning, we have the detection. So on the real-time basis, we can monitor how the air conditioners are working, how the cell parameters are there, whether it's the voltage, the current, or the SOCs or SOH values. All those things we can monitor real time, and again it gives us the advantage of getting prepared in case of any fault or any issues. And the third advantage we are giving in terms of the safety point of view is the isolation. If any fault, any issue in the one battery pack, we can isolate that pack alone, and rest of the system can continuously work. So we give more energy and more available capacity by having the individual component level isolation instead of the whole system is isolated. And the last but not the least is the fire extinguishing system. We have automatic fire extinguishing system, and we are adding the another advantage and the feature in the system is that when you have typically fire and anything, the explosion can happen on the front side or the back side of the system. But since there is a possibility that the people or the humans can be around the product, so we are giving an option. We are making sure that the product, if at all explodes, it explodes from the top side, not from the front side or the back side. That way there will not be any casualties or there will not be any fatalities. So after the safety, we will see how we are giving more energy. Because if you remember the first slide where I mentioned like what are the challenges we see in the market is the safety, another is the lower available energy. So we are giving the more than 5% more energy by having the pack optimizer embedded into the pack level itself. So it gives us the advantage of avoiding the mismatch losses, giving a high available capacity, and also eliminating only the faulty pack in case of any fault, and the rest of the system can work continuously without having any impact. And the reliability itself, again, this is also another feature of the pack optimizer itself. One battery pack having issue, we can isolate again with that optimizer itself without shutting down the overall system. So this is also again another feature of the pack optimizer. But the key advantage, if you see with the other available solutions or the traditional centralized solution, is that our system is a modular. If you see our components, each one is having very low capacity. We are adding more capacity by adding more components into the system in the series and parallel. But if you see on the PCS side also, our PCS capacity is 100 kilowatt, which is very small. But if you required capacity is like say 500 or 600, we can connect more number of PCS in the parallel, we can achieve the required capacity. But in the traditional systems, the PCS capacity is like a 2 megawatt or 1 megawatt, just very large capacity. But the problem with having large capacity of PCS is that one PCS is fails. If there is an issue in one PCS, not only the PCS is down, entire battery capacity connected to that PCS also is down. So you're not able to utilize the batteries as well as the PCS, and in one shot you will have huge power loss. So that is the one advantage we have with the string concept. Since our products all, whether it's a solar or the storage, we go with we prefer to have the string level concept because of these advantages of avoiding the mismatch losses and also having high reliable power supply. So yeah, coming to the smart O&M. So this is the very in-depth concept, but I will try to be brief here. So SOC is nothing but a state of charge. As and when batteries over the time, let's say we have installed batteries today, and after 1 year, after 2 years, the SOC difference, the state of charge difference between battery packs will continue to increase. So let's say we have one battery pack today, SOC is like let's say 90 percentage, and another one is a 95 percentage. So it has the 5 percentage difference of SOC difference. But after 1 year, this 5% can, the difference of 5% can be 10%, can be 15 percentage. When you have a system where the battery packs, each one is showing different SOC, each one is showing different state of charge, it is very difficult for the EMS or the grid operator to know how much to charge the system, because one battery pack is saying I have 90% capacity is available, but other pack is saying I have 80% capacity available. So how we will charge when you have different battery packs with the different SOCs? It's very difficult to charge, also discharge, and also overall system performance itself will get affected. So that is the challenge with respect to the traditional solutions, because to reduce these SOC differences or to calibrate these SOC differences in the traditional system, they have to send engineers at the battery express to the site, and they have to identify what is the SOC difference in the all these battery packs manually. So that is a very time consuming and tedious process, because if your system is a smaller, let's say 500 kilowatt hour, this maybe it takes a couple of days. But if a system is let's say 1 megawatt hour or 2 megawatt hour, 3 megawatt hour, because you have more number of battery packs, checking each and every battery pack and identifying what is the SOC and bringing the SOC to the one common value, either by doing active balancing or the passive balancing, it is very time consuming. You need a lot of man resources, you need a lot of equipment, tools, and the experts have to maybe fly from China to the site. So all those complications are there with related to O&M. But in our system, we have something called automatic SOC calibration, because of we have embedded artificial intelligence and big data components into the system. So whenever the SOC range is, let's say, more than 3%, the difference is more than 3%, the system does automatic SOC calibration without needing to send any people, any experts to the site. The system will do automatic SOC calibration. So that is a very key advantage with respect to this product, because this will reduce a huge cost, and reducing of the cost is nothing but with very low LCOS. So this again will benefit the investors, the developers. When you do the financial model, you realize that this is a very key advantage, and you will also able to have very fast rate of returns. So maybe like within 6 years or within 7 years itself, you can have the returns from the product. But when in the traditional systems where you need to send people outside, and it's a very complicated process, your cost is very high, it may take like 10 years to have the returns on the product itself. So let's see how this systems work and how we will connect the system, how many systems we can connect in the parallel. So this is a solar system. We have a solar module, solar inverter, and the same way we have the energy storage cabinet, which is our C&I product. We can connect maximum 5 in parallel, which means we can have up to 1000 kilowatt hour, nothing but 1 megawatt hour, and up to 500 kilowatt of capacity. So this is again modular. So we can have 200 kilowatt hour, 100 kilowatt. But if we need more power, more energy backup, we can add more and more system into the parallel. Right now, our system supports up to maximum 5. Like we can go up to 1 megawatt hour. If you need more than then, also we have other product called our utility product, which again starts from 1 megawatt hour. So right now we can connect. We have this product supports the AC coupling, and we need solar inverter, also the PCS to convert to couple at the AC side. And as I mentioned, this product is a CNA product. So the output voltage of the PCS is the 400 volts. Depending on the evacuation voltage, depending on the where you want to connect, you may have to add the step up transformer. And this product is a 0.5C, works up to maximum 2 hour backup. Right now we do not have 1C product, only supports the 0.5C. And in terms of the uh, operational maintenance and the doing installation activities, we recommend to leave up to 5 meters of area around the cabinet itself, uh, because to replace the battery pack or anything, we may have to use the forklift, and forklift may need some area to move around the product itself. Some of the success stories we have done with this particular product. So this is the case with the pick shaving. We have done one project in China, where we are trying to reduce the um, so carbon reduction, and also we are trying to do the peak shaving of the peak shaving and avoiding grid reconstruction. So I want to give a small example just to everyone understands properly. So when you have a system, let's say is a 1 megawatt power or 1 megawatt load system, it is connected to the existing grid. But if your factory needs to add more load, you added more components, more load into your factory. Now you need 1.5 megawatt of load power from the grid itself. But the grid and grid infrastructure, grid distribution transformer, everything is rated for 1 megawatt. But suddenly, just because of you have added more components and more loads into your factory, you need to take 1.5 megawatt from the grid. But grid cannot support 1.5 megawatt because it is designed for the 1 megawatt. In that case, either you have to update, either grid authorities have to update the grid infrastructure, add the bigger transformer, replace the transmission line and everything. That involves a lot of time and also involves a lot of cost. But in that case, we can add this battery energy storage component, so that excess 500 kilowatt of load alone we can give to the battery system, instead of going through the elaborative process of updating grid. That is the time consuming, also cost point of view, also very expensive. So we can add, in those cases, we can add the energy storage component of this product. We can add 500 kilowatt of C&I energy storage cabinet, and only for powering that load we use this system. Rest of the 1 megawatt we can continue to take from the grid itself. So that is one case. If you see another case, we have this is a time of use. This is, let's say, this case not applicable in the Middle East, but it could be applicable in the near future. So let's say, when you are taking energy from the grid, and the grid has different electricity tariff at different times. At the peak time there is a high electricity tariff, and the low tariff time, you can charge the battery and discharge the battery during the high tariff time. So again, this will help you to reduce your factory electricity consumption cost, because you may charge the battery during a low tariff time and discharge the battery. Instead of taking energy from the high tariff time, you can use the battery to reduce your cost. So this is again another case when you have multiple tariffs during the day of the time. Third application I want to give is the maximum self-consumption. Here in this case, you are just trying to improve the solar penetration. You are not letting any energy wasted through the clipping, or excess solar energy is being charged to the battery, and use it to reduce the dependency on the grid or diesel generators. So that's it from this product. I'm happy to answer if you have any questions.
Thank you, Mr. Ayub. I will now be screening some of the questions.
Yes, share the iSitePower-M various priority modes and settings with us. Definitely, yeah, we will do that. You have to approach me, through mail or the contact. We'll share the necessary documents with you, and also we will also help you when you have a project. You can share us the what is the application, because all these modes, everything depends on what is your application, and we will help you in deciding and selecting the parameters and the sizing of the product itself. So we have a user manual and other technical documents. Those documents I can share with you. Yes, I said power is fully integrated into the Fusion Solar. Yes. Uh, can you show the question once again? Yes, we can iSitePower-M supports the integration under the Fusion Solar and both app and the web-based system. How BMU BMS works. Uh, Yeah, Dimitri, I will get in touch with you because this is not a straightforward question. How BMS and BME works. Again, this is some proprietary information, right? Because every supplier will have how they want to manage the battery management system. What are the critical components they want to monitor? This is a very proprietary information. Again, this is something related to the supplier itself, but the consumers or the customers, it does not matter, because at the end of the day we are giving the guarantee. How the internal systems, we are doing the algorithms, some programmings, it actually does not help to the end consumers.
That's all the questions we have for now, Mr. Ayub. Thank you, audience, and Mr. Ayub. So, with this, we come to an end of this masterclass. A big shout out to all our attendees for extending your time and support for this event. And thanks to our partner Huawei for their support to organize this event. We promise to be back with another exciting session soon. The floor is now open for networking. Thank you, everyone.
Thank you everyone, and advance happy to everyone.